come down and continue on. They'll have another.
This is a story about cars and cameras in big cities. It's about English heritage and a Carolina hurricane. And it's a story taking place almost everywhere in the world. Delivering 60 million megawatts of power to 10 million New Yorkers every day isn't a problem unless something breaks down. And if it does, the action necessary to solve it starts here at the Energy Control Center. From this room, Consolidated Edison monitors over 85,000 miles of underground cable. And they know what happens when the system fails. At its best, it might be inconvenient. At its worst, lives are at risk. This complex electrical chain is no stronger than its weakest link. So the links, the splices in the cable, have to be reliable. One of Con Ed's problems was linking old paper-insulated cable with the new plastic cable. They wanted the splices to last, and they wanted ease of application. Problems like these aren't solved overnight, but at Raychem, we had a head start. We already knew how to make tubing that would shrink to a predetermined shape when heat was applied.
Splice this paper cable.
It's the result of our development since 1957 of something called radiation cross-linking. What we begin with is a typical polymer made of long molecular chains. The chains are composed of carbon atoms flanked by pairs of hydrogen atoms. We direct high-energy electrons at the polymer. The electrons cause some of the hydrogen atoms to break free, creating chemically reactive sites. When two polymer chains with missing atoms come close together, we get a permanent chemical bond or cross-link. The polymer now has greater temperature resistance and is able to withstand environmental and mechanical abuse. And it acquires the almost magical property of shape memory. The secret is in the crosslinks. When we heat the polymer, it becomes soft and pliable. In this state, we can expand it to a shape it will hold when it cools. When it is reheated, the crosslinks will pull the polymer molecules back to their original shape. For Raychem engineers, solving Con Ed's problem meant marrying oil barrier technology with heat shrink capability. For Con Ed, the result was a splice that can be done quickly and easily, and one that can survive for a very long time in the inhospitable world beneath the city streets. If the tunnels beneath the city are inhospitable, the space under the hood of a race car is downright hostile. But Raychem's heat-shrinkable tubing is here, too, protecting the engine's electrical harness. When you're pushing the car to speeds over 200 miles per hour, it's not just your success that depends on the harness, it's your life. In the competitive automotive industry, success also depends on reliability. In France, Renault realized our heat-shrinkable products could help them deliver on their warranty. Of course, the electrical wiring harness would have to survive high temperatures, intense vibration, and corrosive fluids. And surprisingly, even a small amount of water in the wrong place can damage the electrical harness. So you might end up without anti-lock braking, electronic fuel injection, and even the ability to start the car. So we put a layer of sealant inside our heat-shrinkable tubing. And with the spaces between wires and terminals sealed, there is no room for any fluids. And we designed special equipment to make installation fast and efficient. It's an old cliche, but it's true. In road cars or race cars, there is nothing like being on the winning team. Of course, maintaining the competitive edge is as difficult in Japan as anywhere in the world. We had a product that we knew would solve a problem that most people didn't even know existed. If improperly installed, high-energy batteries used in laptop computers and many other products can short-circuit, then overheat. To prevent this, we developed a device based on conductive polymer technology called polyswitch. Now, instead of overheating, the polyswitch device interrupts current in a faulty circuit. Matsushita, the largest battery manufacturer in the world, wanted them. And Matsushita wanted the product delivered with quality so assured they'd never have to inspect a single device. And they wanted $20 million a year for products like toys, computers, and cameras. Matsushita also wanted just-in-time delivery. The required quantity, no more, no less, delivered as needed. We knew that to do it, we would have to combine cellular manufacturing, statistical process control, and robotic assembly. It sounds complex, and it is. And like most elegant solutions, it looks simple now. But like this traditional drumming, it's the result of hard work, knowledge, and a commitment to excellence. What seems impossible in one generation seems almost easy in another. When the roof of this English manor was built, a winter's snow could bring dozens of shovelers up here in haste. They knew ice buildup could cause water seepage and serious damage to the ceilings and treasures below. Now the gutters are kept free of ice by an ordinary-looking cable we call ice stop. The magic comes from our pioneering work in conductive polymers. We make the cable core conductive by blending carbon particles into a polymer base. We then extrude this material over two parallel wires and cross-link it. Now, when electricity is applied to the cable wires, a current is conducted across the microscopic carbon networks. The networks form miniature heater circuits, and the cable warms the surrounding area. As the cable itself gets warmer, the plastic expands until most of the carbon circuits are disconnected. Then if the outside temperature drops again, the plastic contracts and circuits are reconnected. The result? A self-regulating system that delivers just enough heat to keep the snow melted and the water flowing off the roof. Ice stop cable is ready whenever the snows decide to come. When hurricane warnings went up in Charlotte, North Carolina, we did our best to prepare. We knew our customer, Southern Bell, could suffer serious damage. Reports indicated Hugo might be bad. It was worse than anyone expected. Charlotte's phone system was entirely knocked out.
Don called and we've got an order from Charlotte. We need to get the material to them just as soon as we can.
We set up a 24-hour hotline for our customers. And we brought in components from as far away as Europe. Southern Bell brought in linemen from neighboring states, linemen who needed to be trained. We trained them on our simple-to-install track closures. With the thousands of splices Southern Bell had to make, the time saved meant Charlotte's phone system was up and running within days. Southern Bell wanted the job done quickly. They also wanted it to last. The unique gel end pieces meant the cable could be sealed quickly and easily.
Seal up the ends.
I got a hold of one the other day and I opened that thing. I thought to myself, man, that's easy compared to the others. I said, I like that. I love it.
We've solved a lot of problems for a lot of people all over the world. We've developed quality products based on innovations in materials science. And we continue to upgrade our products and improve our processes and expand in our technologies, like liquid crystal windows, touch screens, and fiber optic distribution systems. What it all comes down to is doing what we like best, understanding the problem and finding the solution.